Welcome to a presentation of EDAptability's total scope. My name is Tobias Strauch and I would like to thank you for listening to this presentation. We also call it a 100% RTL at speed debugger for ASICs and FPGAs, and you soon will see why. In the beginning, we will record some problems, pros and cons of FPGA debugging methods. After this, the structure of total scope is explained as well as your benefits when using this tool environment. Very well known is the method of changing RTL, going through the complete synthesis, place and route process over and over again. Mostly you can see the signals you are interested in, and in case it has a more complex type like a record for instance, you can debug the type as well. But this method is also well known for the sometimes painful manual modifications, but for sure the turnaround time of the complete synthesis, place and route process can be very time consuming. In some cases the modifications change the combinational logic so that the test case behavior changes or a timing problem occurs now. And of course you cannot look inside memories. Another method is introduced by Xilinx, with a quick routing of internal nets to the IOs and their connection to an external logic analyzer for instance. You can see the behavior of internal nets. You have a quick turnaround time and you see the signals at speed. The problem is that most nets have weird names and most of the time you simply cannot find the signals you need to debug. Either the signal names have changed or the signals simply don't exist anymore due to synthesis rules of combinational logic. If you use the readback function of some FPGAs, you can look at most of the nets, including memories. But here again, you have the problem with weird signal names and signals that don't exist anymore. But the main disadvantage is that for a continuous readback you have to slow down the system, which is not possible in most of the in-system verification methods. Another method uses a construct of logic duplication, input pattern streaming and post simulation. Here again you can debug the signals and the types of your interests. Unfortunately, you cannot post simulate the behavior of asynchronous clock domains without easily running into a pattern mismatch problem. Most of the time a logic duplication is simply not possible at all. Another killing point of course is that, for example, if the bug appears 10 seconds after reset in a 100 MHz design, it is simply not possible to post simulate 1 gigacycles of the complete design. Finally, we need to mention some facts about the hardware you might use for different debugging methods. We already said that logic analyzers are mostly very expensive. Regarding the FPGA resources, the FPGAs of course have a limited number of IOs. The streaming capabilities are sometimes limited, in case you use JTAG for instance, and if you are forced to implement huge memories for pattern streaming or pattern saving, the place and route time rises exceptionally high and the debugging can become very painful. So far we discussed the problems, pros and cons of various FPGA debugging methods. Let us now talk about the structure of total scope. After reading the design, the first step is the instrumentation of the RTL, which is then dumped in the original format again. After the classical synthesis, place and route steps, you can run the design on the FPGA. Total scope now configures the implemented test structure so that the data can be streamed during the test case. You might need to run the test case multiple times so that all necessary data can be streamed out. After streaming has finished, the data are then post-processed and displayed. That means only the necessary part of the design is simulated with the implemented simulator using the streamed data. All signals can then be viewed and the starting of the simulation can be anywhere in the time zone. So let's say 2 minutes after reset, wherever you want to look at the signals. Total scope also works with alternative cable hardware like all the cables from Altera and Xilinx. A memory on the FPGA and the JTAG interface is then used to stream the data. That means you only have to purchase the software for debugging, and if you want to work faster by using an optimized streamer, you buy EDAptability's cable hardware later. Now let's have a closer look at the additional structure we implement in the design. Basically, the outputs of the registers are connected to the outputs of the design. That means the only direct impact on the design structure is an additional fan-out of the registers. But we do not use all of them, only some key registers are used for streaming the data. Of course, you cannot route all the outputs of the selected registers to the FPGA IOs. This is why a multiplexer is implemented, which itself is configured by the tool using the streamer. For the overloading of various streaming results, a signature of the design state is generated, and it is also streamed out to the database. So let's put everything together again, and you can see why we call it the 100% RTL at speed debugger. You can debug and view the complete RTL without having an impact on the structure or timing of the design. Now let's go through the different points again that were made when we listed various pros and cons of other FPGA debugging methods. One major benefit is that you have 100% RTL visibility of the design. Any signal can be viewed in the original type. You can look into any memory within the design. No painful manual RTL modifications. You can guide the tool through some implementation options, but everything can be done fully automatically. If the original RTL is changed, it only takes a few seconds to update the implemented RTL code. Only the necessary files are changed, so you still can use the incremental feature of the place and route tool. No slowing down of the design and no post-simulation mismatch at asynchronous clock domains. You can debug the design at the original design speed. No additional synthesis, place and route steps if you need to debug various signals. The design modification is done only once and upfront within seconds. If you need different signals from the other corner of the design, we just need to reconfigure the test structure online during the debugging process. No modification of combinational logic. The design remains the same, no impact on the timing. No duplication of the logic. We measure only maximum 10% area increase through the implementation of the test structure. The post-simulation is started very close to the beginning of the time frame you are interested in. You can have a look at multiple time zones during debugging. Only these particular time zones are post-simulated. It is not necessary to do a complete simulation starting from reset. Even if the bug appears 10 minutes after reset, you only need to post-simulate a few hundred cycles, for instance. No expensive logic analyzer is needed. There are no limited streamer capabilities because we are using streaming optimized hardware. Alternatively, you can start with your existing interface environment using Altera or Xilinx cables and purchase the optimized streamer hardware later. So the total scope environment has astonishing benefits compared to other FPGA debugging methods. From the user perspective, it is only necessary to read the design, press the implementation button and use this new RTL for synthesis, place and route instead. If you now want to see any signals without slowing down the design, you just have to select the signals and total scope is taking care of the rest. Either the test cases are run automatically or you start them manually. After that procedure has finished, you see the signals in the waveform viewer. You can then select different signals at different time zones, and the signals can then be displayed within a very short turnaround time. In the end, we would like to thank you again for your time. We hope you liked the presentation and you would like to know more about EDAptability's total scope. We would be very happy about any kind of feedback, and please drop us an email to feedback@edaptability.com. Thank you again, have a nice day and goodbye.